Hello, my name is Smail and I will presenting about our assignment for the Bmmh 3574 for the transportation, air conditioning and refrigerants. And for this topic today is about assignment for the air conditioning system in an aircraft. And we will proceed to the first slide. As you can see here from the first slide, there is our group members. And our group are ADIE ZULFIKRI, there's me and me, HARISWAR Smail. Next person is HAZRIQ, HAKIM and JULAILI, and HARISHWAR, ANAK, MOHAN. And we proceed to the next slide. Now for the next slide, for this slide, I will introduce about in the introduction for the aircraft hatchback. An aircraft hatchback system is slightly different when compared to other transportation hatchback systems. This happens due to the pathway an aircraft uses. An aircraft uses a pathway where the layer in which the aircraft fly is the troposphere or the layer closest to the earth. Although within this layer, each type of aircraft even use a different altitude depending on its needs. To ensure the comfort of the passenger when the hatchback system is functioning, the function for the of the hatchback in the aircraft are heating. The heating function of the hatchback system is responsible for maintaining and comfortable temperature within the aircraft cabin. And for the next point is ventilation. For the ventilation is essential to circulate and exchange air within the cabin. The hatchback system constantly supplies fresh air from the outside and removes stale air, or the other term is moisture air, preventing the build-up of odor or contamination. And we proceed to the last point is air conditioning. Air conditioning is a critical aspect of hatchback system, particularly in a warmer climates or during summer months. It helps regulate the cabin temperature by cooling the incoming air, ensuring that passengers are comfortable and protected from the excessive heats. And we proceed to the next slide. There is history of the aircraft. A long time ago, planes didn't have a way to make air inside the cabin to feel good for people. But then they made a special system that keep the air at a good level so people won't get sick from being up high. This due to altitude changes. And it is made flying more comfortable, but it didn't have a way to make air warmer or cooler. Yet, in 1940s and 1950, improvement in airplane technology allowed for a basic heating system to be integrated, which is use air from the engine or combustion heater to warm the cabin. However, cooling was still reliant on natural ventilation and limited insulation. As a commercial aviation grew rapidly in the 60s, there was a greater need for the advanced hatchback system, leading to manufacturers to develop a special air conditioning system for airplanes. This system used compressed air or engine bleed to effectively cool the cabin or regulate the temperature. In Plug-in CD 2014, in the following decades, aircraft hatchback system improved significantly in terms of efficiency, reliability, and passenger comfort. The introduction of the advanced technology such as steam cycle cooling and digital continuity system allow for a better temperature and humidity control. That's all for me. I will proceed to the next slide for the system in the aircraft. Thank you.
Assalamualaikum. My name is HAZRIQ HAKIM, and today I'm going to talk about the system and or technology of the diagram for the aircraft air conditioning system or ACM air cycle module. So, the fresh air that we gain from the uh, higher altitude that goes into the ram air through the first primary heat exchanger and then flow to the secondary heat exchanger. Right, that's what we call the bleed air that going through the primary and then flow into the secondary heat exchanger, turns into a cooler air. So the cooler air flow to the what we call the turbine or compressor. Okay, the compressor will compress the air and then make it a cooler air. So the cooler air go through the water separator. So the water separator is used for separating the water that condense in the system, and then flow to the water separator for anti-ice valve. The anti-ice valve is used to make sure to prevent the frost or freeze that happen in the system or the exit of the turbine. So the cooler air flow through the mix manifold. So this is the mixing chamber. Mixing chamber come from the engine too. This is the hot air. Hot air come from the engine too, and then mix with the cold air, so that the engine cooling system come from here. All right. So the through the passenger cabin. All right. And then the heat exchanger cycle the hot air. The secondary receive the hot air from the compressor and then release it, and then cycle it, turn it into the cooler air, which is mixed with the ram air, and then turn into the cooler air. So how the cabin receive the cold air or the cooler air? The passenger cabin receive the cool air using the auto temperature controller uh, from the air mix valve. So how they control manually from the cockpit. That's all from me. Thank you.
A very good day, sir. My name is HARISHWAR MOHAN from Bmmh S1/2. My matric number is B0920103668. So today I'm going to explain how the theory how the air conditioning works on aircraft. So aircraft typically use two different types, which is air cycle and also vapor cycle. The air cycle is used on most turbine powered planes and relies on the engine or APU during the air conditioning process. The vapor cycle, which is similar to those found in our homes, cars and also reciprocating aircraft. So while we discuss about pneumatic system, the air cycle air conditioning system receives air from the aircraft pneumatic system, which is supplied by the bleed air tap offs on the engine or the APU pneumatic supply. When the aircraft is on the ground, an external pneumatic air supply source can also be connected during normal flight. The engine bleed air is directed through valves, regulators and ducting to supply the pneumatic manifold, which then provides air to the air conditioning racks and other important systems, including anti-ice and also hydraulic pressurization. Vapor cycle. Reciprocating engine aircraft do not have a bleed air source, so an air cycle system cannot be used to condition cabin air. Instead, most non-turbine aircraft used vapor cycle air conditioning, which only cools the cabin and does not provide pressurization. If the aircraft pressurized, it used other sources of pressurization. The vapor cycle system is a closed system that transfer heat from inside the cabin to the outside and can operate on the ground in flight. Next slide. So on next slide, the diagram shows pneumatic and vapor cycle. Pneumatic system, the engine air intakes, so it flows through the heat exchanger, then it flows through high temperature bypass and also air condition. When the air flow through the air condition, there's got a mixing unit, then the air distributed to the cabin 1, cabin zone 1, zone 2 and also zone 3. So for vapor cycle, first hot high pressure bleed air is further compressed. Second, compressed air bleed air is cooled by outside air via heat exchanger. Third is air expanding to ambient pressure turns expansion turbine is greatly cooled and drives compressor. So in third slide we're going to see about the system operation. The operation of most cabin temperature control system follows a similar pattern. Sensor located in the cabin cockpit, condition air ducts and distribution air ducts monitor temperature, which is then processed by a temperature controller in the electronics bay. The cockpit features a temperature selector to adjust the desired temperature, which is compared to the actual temperature signals received by the controller. Circuit logic process the selected mode inputs with an output signal sent to an air cycle air conditioning system valve. This valve, known by different names depending on the aircraft manufacturer and also environmental control system design, blends warm bleed air with cold air produced by the system. By modulating the valve in response to the temperature controller, air of the desired temperature is distributed throughout the cabin. That's all from me, sir. Thank you.
Assalamualaikum. My name is ADIE ZULFIKRI bin MAZLAN. Okay, I will proceed about major components of the air conditioning. There are 8 major components of the air conditioning of aircraft. One of them are the air cycle machine, ACM. An ACM comprising a compressor and a turbine mounted on the same shaft. Another major components are the condenser. Condenser uses refrigerated turbine discharge air to cool incoming bleed air to a temperature low enough below the dew point temperature for moisture condensation to occur. Another components are the water extractor. The water extractor remove the water from the moisture produced by the condenser. Another part is water spray nozzle. It is located at the secondary heat exchanger inlet and sprays on it water drain from the water extractor in order to increase the cooling capacity of the heat exchanger. Okay, next, advantages and disadvantages of air cycle machine and aircraft. There is 3 advantages and 4 disadvantages of air cycle machine in aircraft. First, for the advantage is efficiency. Air cycle machines can be more efficient than other cooling systems such as vapor cycle systems due to the utilization of ambient air as a heat sink. This eliminates the need for a separate condenser and reduces the overall weight of system. Simplicity. SCMs typically have a simpler design and fewer moving parts compared to other cooling systems. This simplicity can result in reduced maintenance requirements and lower risk of mechanical failure. For disadvantages of air cycle machine in aircraft, one of them are cooling capacity. Air cycle machines may have a limited cooling capacity compared to other systems, such as vapor cycle systems. This limitation can be disadvantaged in situations where high cooling demand is required, such as in large commercial aircraft or in hot climates. Next, extreme environmental conditions. Air cycle machine may face challenges in extreme environmental conditions such as extremely high or low temperatures. Additional measures or modification may be required to ensure proper operation and performance in such conditions. As conclusion, the HAZRIQ system is a critical component of modern aircraft, ensuring passenger comfort, safety and well-being. By providing heating, ventilation and air conditioning functions, it creates a pleasant and controlled environment throughout the flight. The advancement in HAZRIQ technology has significantly enhanced the flying experience, making air travel more enjoyable than ever before. Okay, that's all from us. Thank you.